Okay, well, let's start out with this example. The question is there a difference uh, in between the education majors and all of the students at the university? The word difference we know signifies into this, and that means that we instantly know this is a two-tailed test because of the word difference, right? Um, okay, so the first thing we should do in a word problem is we should write down what we have, right? So we know that the GPA of all the students is 2.7, and we know that that's a population mean, right? And we know that the education majors, their GPA is 3.0, and we know that that is a sample mean, right? And the third thing that we know is that the N, because we can't look at all the students, we have to look at a sample, is 117, right? And we can use a 5-step model here, right? We're not given an alpha. So since we're not given an alpha, we know we'll use the 5%, which is the standard alpha in social science. So we know our alpha is 0.05, which equates to a z of 1.96, right? All right. Well, let's just follow the 5-step, right? The 5-step says 1 is our N greater than or equal to 100. And we say yes, right? So we'll move on to the second step of the 5-step. What kind of test is it? We know because of the word difference that it's a two-tailed test. All right? So we move on to step number 3 in our 5-step process. We know it's a two-tailed test. We know that the alpha, because 1 wasn't given, is 0.05, which is a z of 1.96, right? And the next step is we'll go to the z obtained formula, right? And then our last thing we'll do is we will determine whether or not we'll accept or reject the null hypothesis. Okay, great. So let's move on to the actual steps. So we've done steps 1 through 3. So let's move on to step number 4, z obtained, right? So our z obtained formula is a pretty easy formula, right? It is the mean of the sample minus the population mean, standard deviation divided by the population minus 1, right? So we've already written down what we got, right? So we know that mu is 2.7, and we know that the sample mean is 3.0, and we know that the standard deviation is 0.70, right? And we got N of 117, right? So if we plug this stuff into our formula, what we get is 3.0 minus 2.7. We have a standard deviation of 0.7 divided by 117 minus 1, right? So if we actually just if we do the problem, let's just do the stuff on top first because it's just that simple. So we'll get 0.3 on the top. We know that this means to divide, right? So the first thing we'll do is we know that 117 minus 1 is 116. So the first thing we'll do is we'll take the square root of 116, which we know, we'll use our calculators to do that, is 10.77, right? And we know we're going to divide that into 0.7, right? So the next thing we do is we divide 0.7 by 10.77, and we get this for our denominator, 0.65, because we'll round up 1, divided into 0.3. So we'll divide 0.3 by 0.065, and that'll give us a Z obtained of 4.62, right? So our Z obtained is 4.62. So we need to determine whether or not this is significant or insignificant, right? So we know that using our normal curve, that our rejection region, let's call this rejection, is a negative 1.96 and a positive 1.96. And we know that anything within this rejection region to infinity means that we will reject the null hypothesis. Our Z obtained is, let's use green here. Our Z obtained is way over here at 4.62, right? It's 4.62. This is definitely in the rejection region. Since it's in the rejection region, we can see that it's in the rejection region. This rejection region goes on to infinity, right? So we know this is in the rejection region. So we know that we will reject the null hypothesis. And there is a statistically significant difference between the education majors and the rest of the students. Okay. Also, we could be given this rejection region as a p-value, right? If it's a p-value, if it's greater than 0.5, we reject. If it's less than 0.5, we accept.